Hello, you are most welcome. I'm teacher Ivan from Wuna Educational Services. We are continuing with derived quantities. Previously, we saw what physical quantities are. The two categories of physical quantities, which were fundamental or basic quantities and derived quantities. We saw what fundamental quantities are and their examples. So today we are to look at derived quantities, what they are and how do we derive them. Derived means obtained. So meaning that derived quantities are obtained from fundamental quantities. Therefore, derived quantities, these are physical quantities that can be expressed in terms of the fundamental quantities of mass, time, and length. Then, since the quantities are derived, therefore, even their SI units are derived. For instance, if we have area is length squared, and since length is measured in meters, therefore it will also be meters squared. Volume is length cubed, therefore the SI unit of volume is meters cubed. Density is mass over volume, whereby mass is in kilograms, volume is in length cubed. Hence that will be kilogram over meters cubed, thus giving us the SI unit of density as kilogram per meter cubed. So this is a derived quantity and this is its derived SI unit. That is how we derive the quantities and their respective units. However, today we shall look at some of these quantities in details. So we shall start with the area. However, before we continue, I kindly request you to subscribe to all our YouTube channels from Wuna Educational Services, that is Teacher Ivan's online class, Wuna e-learning platform, and Wuna Kids platform. Please subscribe, like, comment, and share with classmates, family members, and friends. Don't forget to hit the bell so that you get notified whenever we have new videos. Thank you. Let us look at area. Area is defined as a measure of size of a surface. Area is the measure of size of a surface, and its SI unit is meters squared. Since area is given by length squared, therefore it is in meters squared. So this is its SI unit. However, area can be measured in many other units. For instance, we have kilometer squared, hectometer squared, decameter squared. We have the meter squared, which is the SI unit. We can have decimeter squared, can have centimeter squared, millimeter squared. Those are the other units. This is the SI unit, and these are the others. So when we are looking at conversion, we can convert from any of these to the other. For instance, if we are to convert 1 kilometer squared to meter squared, we know that 1 kilometer is equivalent to 1,000 meters. Then 1 kilometer squared is the same as 1,000 meters squared, which gives us 1 kilometer times 1 kilometer equaling to 1,000 meters times 1,000 meters, giving us 1 kilometer squared equaling to 1 million meters squared. So meaning that 1 kilometer squared is equivalent to 1 million meter squared, and so on. If we are to change meter, 1 meter squared to centimeter squared, we do the same. Remember, 1 meter is equivalent to 100 centimeters. So we square both sides. So that gives us 1 meter squared equaling to 10,000 centimeters squared, and so on. So that is how we convert units of area from one to the other. Then, after looking at conversion, did you know that area has two types? Yes. We have what we call the cross-sectional area and the surface area. Let us look at how we get cross-sectional area. Cross-sectional area is area of two-dimensional figures. When I say two-dimensional figures, I mean I could literally say a map, because if I'm to view a classroom from above, I'll view it in a rectangular form, and this is a two-dimensional figure whereby I will only see the length and the width. This is a two-dimensional figure. So for two-dimensional figures, the area is cross-sectional area. This is what we call the cross-sectional area. So now we have what we call the surface area. Surface area is normally calculated for three-dimensional figures. For instance, this is, let's take this to be a box as viewed from above. When I view a box from above it, I will only see the length and the width. I will not see the height. When I view a box from a side, I will see the three dimensions of the box, and this is what I will see. I see what we call a cuboid. So a cuboid is the three-dimension figure. Why three-dimension? Because I see the length, I see the width, and I see the height. This one was two-dimension because when I view a box from above, I only see the length and the width. So what we get here is the cross-sectional area. For the 3D figure, which is now a cuboid, I see all the three dimensions. That is the length, the height, and the width. Now, How do we get and from here we get what we call the surface area. How do we get the surface area? We shall get, because this one has 6 faces. This side has the opposite side on this side, which is not seen. We can maybe trace it. This one has this, they are equal. So we get the area of this plus area of this. Even the same applies to this, has unequal but opposite face, the other side. So we get the area of this and that. Then even the top has its base down. So those are the 6 faces. Now, if we are to get the total surface area, we get the area of the 6 faces and add them. For instance, here the area of this will be length times, it will be length times height, plus we have another opposite side face, it is also length times height, meaning this is giving me, this gives me 2 length height. Then plus we have height and width, so that is height width, but it has its opposite, the other side, it is also height and width, so giving me plus 2 height width. Then we have the bottom and the top, that the bottom and top is length and width plus still length and width, one for the bottom, the other for the top, so it gives me plus 2 length width, meaning the total surface area here would be 2 is a common factor, length times height plus height times width plus length times. So this is the total surface area of a cuboid. Therefore, we have 2 types of areas. One is cross-sectional area, and that one is for the 2-dimensional figures. 2 is the surface area, and that one is for 3-dimensional figures. Otherwise, thank you. That is what we had to look at concerning area. Please don't forget to subscribe, like, comment, and share. Click the bell so that you get notified whenever we have a new video. See you next time.